welcome to another tutorial with Ola Fit on MTS 105. Yeah, today we're going to continue with trig functions. So let's go right in. Now let's consider this question. Yeah, you're in your exam hall and you're faced with this question. You're like, how on earth can they give you this kind of thing? The truth is, you can be given. Yeah, it is actually easy to. It's easy to get if you know what you're doing. It is easy to get if you know what you're doing. So stick around for the shortcuts. Yeah, it has shortcuts. Okay, I know that's what some of you are waiting to hear. Okay. Now, firstly, let's understand what this is. Now, you see this question like this, and you're told to find R and find alpha. Okay, now, firstly, you're told to this equation, this one on this side, you're told to convert it into this form: r cos alpha plus cos theta plus alpha. So we already know. Let's remember that what we've treated in the past. Remember that cos theta plus alpha equals to cos theta cos alpha minus sin theta sin alpha. I hope you remember that. Okay, having known that, we can then say r cos theta plus alpha equals to r cos theta cos alpha, then r sin theta sin alpha. Okay, so since this is it, we can then say cos theta sin theta is equivalent to r cos theta cos alpha, isn't it? We can say it's equivalent since we already established that these two are the same from the beginning, so we can say they are equivalent. We can then say this is equivalent to this since they are the same right from the beginning. Okay, now from what we see here, we can see that some things are already clearing out. Let me use color to separate it. We can see r cos alpha cos theta minus r sin alpha cos r sin alpha sin theta. You can see that I decided to put it in color so that we can see what is going on. We can see that we have cos theta here, sin theta here, sin theta here. So we can then say the coefficient of whatever this is, the coefficient, we can make it r cos theta, and whatever the coefficient of this is, we can make it r sin theta. So let's assume the coefficient of cos theta here is a. Let's just assume the coefficient here is a and the coefficient here is b. We assumed, so we can then say a equals to r cos alpha, and we can then say b equals to r sin alpha. Okay, I hope we are getting it. So the question is, we are finding r, isn't it? It is r we are looking for right from the beginning. So we can then say cos r and alpha. We can then say cos alpha equals to a all over r, and in the same way sin alpha equals to b over r, isn't it? Yeah, so we are getting a little step closer to finding r and at the same time finding alpha, because if we know r and we know alpha, we can easily put them here to get the answer. So let's consider a right angle triangle having angle alpha 90 degrees. So cos, if this is cos, then if you are trying to draw out cos here, it means adjacent over hypotenuse, isn't it? So this is a and this is r, and if we are trying to sine, that's opposite over hypotenuse. So we can then say that, we can then see clearly that r will be gotten from this, isn't it? Pythagoras theorem. r square equals to b square plus a square, isn't it? That's Pythagoras theorem. So we've known what r will be like that. Now how do we get alpha? Alpha, since r is not yet known, I want to get alpha. The easiest way to get it is when we use tan. Since we know two sides on this, we know these two sides on this right angle triangle, so we say tan alpha equals to opposite over adjacent, b over a. So we can then say alpha is then arctan b over a, and there you have your answer. It's a simple actually if you know what you're doing, but this is the part you've been waiting for. If you have this kind of question in exam, would you now solve all this? Would you now solve all this and waste your time? So let's pick a question. Sorry, let me go to this side. So let's consider this question. 3 cos, I'm going to solve it. Yeah, I'm going to solve it like the normal way. So we have this question. Now let's try it. We already know that cos theta plus alpha, okay, we even did something like that before, is cos theta cos alpha minus sin theta sin alpha. We remember. So in the same way, we can say r cos this is still the same thing. Let's not bother wasting our time rewriting it. Okay, now since it is this, we can say they are equivalent then. R cos theta cos alpha, r sin theta sin alpha. Okay, so now we can see it coming out already. This place is r cos alpha cos theta, r sin alpha sin theta, isn't it? 3 cos theta 4 sin theta, isn't it? So we can then say 3 is the same as r cos theta alpha, and we can then say 4. Don't put minus 4 because this is minus, this is minus, remember? So 4 equals to r sin alpha. We can then say cos alpha equals to 3 over r, sin alpha equals to 4 all over r. Drawing the right angle triangle. This is alpha, this is cos, this is it 3, and sine, this is 4, so that this is r. So we can then say r equals to what? Square root 4 square plus 3 square, so that's 5. If you solve it, is 5. Okay, so we know that r is 5. Now tan theta equals to 3 over 4. And how did we get it? Opposite first. Opposite over adjacent. That's tan b over a, opposite over adjacent. So then tan would then be theta would then be arctan 4 all over 3, and whatever you get, sorry, I'm not with a calculator here, so whatsoever arctan 3 over 4 is, be the alpha. Then we already know r is 5, so the answer here will be 5 cos theta plus, I think this is 5, I'm not sure, just please get a calculator and confirm this. I'm not with a calculator, so this is the answer. But how would you do this in exam? Because you can't definitely have the time to do all this. That's the fact. Now the shortcut. Let me write out the question again. So you see this in exam and they're like, what is theta and what is r and what is alpha? Find r, find alpha, any of them. It is actually very simple. Your r is looking directly at you and your theta is looking directly at you. This one is your A, this one is your B. then r equals to square root a square plus b square, and that's what 3 square plus 4 square equals to 5. That's just it. And tan, remember tan b over a, 4 over 3, isn't it? I know right now you're like,
Are you serious?
so that's just it. It's actually simple. Like I've always said, you don't have to be extra brilliant before you can pass the exam. Especially all this calculation exam, you don't have to be extra brilliant before you can pass MTS. You just have to be smart.
Got him! Got him!
You're brilliant, not just brilliant, you're smart. Okay, so that's that. Let's try another one. Let's see if what we are doing is actually on point.
Another one.
So this is another question. 2 sine theta minus 3 cos theta equals to r. We have to make it in this form, r theta. We have to make it in this form, r sine theta plus alpha. We have to make it in this form. Okay. So we already know, I know most of you already know this is A, this is B, and you get your answer. Yes, and let's just try and compare it with the answer so that we know if we are doing what is true, the rules are working. So we already know that r sine theta plus alpha from the trig functions we've done in the past should be r sine theta cos alpha plus this should be minus. This should be minus r cos theta sine alpha. Okay, so since it is that, then they are equivalent. R sine theta cos alpha, r cos theta sine alpha. So 2, we can then say this one and this one, this one and this one. So we can then say 2 is equivalent to what? R cos theta, and we can then say 3 is equivalent to r sine theta, isn't it? So cos theta equals to 2 over r, and sine alpha equals to 3 over r. Then when you draw it out, this is alpha, r is adjacent r, sine is 3r, and square root of r would then be square root of 3 square plus 2 square. Then tan would then be 3 over 2. Tan alpha will be 3 over 2. It's still actually the same thing. So do you remember what we said? R equals to a square plus b square. Then tan equals to b over a. Tan alpha equals to b over a. So a square plus b square. You just have to be very careful with this tan. Then 3 over 2. Then alpha will then be arctan 3 over 2. You just have to be very careful with this tan. Very, very careful with it. So basically, that's just it. Like, it is mind blowing. That's just it. So the last one is the inverse trig functions. So well, actually this one doesn't really require much. You just have to understand what inverse trig function is. If you say x equals to arctan y, it means y is than x. So if I say x equals to arc cos 1 over 2, so it means cos x equals to 1 over 2. That's that. And actually there are quite a number of questions that you have there, and so it's important to note that the reciprocal is different from inverse. If I say 1 over sine x, it is not this, because 1 over sine x is what? Cosec x. So they're not the same. So and in the same way cos x multiplied by arc cos x is 1. The same way 1 over cos x multiplies x cos x to get 1. I hope we understand that simple. It's just a simple trick. Okay, so we have quite a lot of questions here. Well, this one actually requires that you understand how to work all these things out. And the truth is, you can't be asked to prove anything, because most of your questions under this is show that this is this, show that that is that. You can't be asked to prove anything in your exam. You can't be asked. So just understand it for the sake of knowledge. You get? Okay? You can't be told to prove. So let's just pick one of the questions you might get. You can get a question like find the value of arc cos 1 over root 2. So we already know from the table, isn't it? So let's say we are finding the value of this. There's actually a table of functions. We have that the circle of function, forgetting what they call it. So now but the simplest way to understand this is this way. If this is x, then we can say cos x equals to 1 over root 2. And if you check the table, cos x is x. If you check the table, cos 45 equals to 1 over root 2. So we can then say x equals to 45 degrees. So that's just simple thing you might get, and they're actually complex ones here too. And let me just pick one of them. And we round it up. Call it a day. So we have this. We have this cos y equals to cos minus 1 x y minus square root of 1 minus x square 1 minus y square. So we have this question, and you are told to show that arc cos x plus arc cos y equals to arc cos xy minus square root open bracket 1 minus x square 1 minus y square, just to show. So let a be cos this and b be cos arc cos y, and let c be arc cos x square minus square root 1 minus x square 1 minus y square. Okay, so we already know what the implication is. We can then say cos a equals to x, cos b equals to y, then cos c equals to this long function. Let me just do it like this. You understand? This long function. That's that. Okay. So since we have this, That's the implication of this third line is the implication of this second line. But the implication of this second line is that from what we have here, since a equals to cos arc cos x, b equals to arc cos y, and c equals to this, we can then say a plus b equals to c, isn't it? This is a, this is b, and this is c from what we have just done in this second line here. So since we have this, it also means that cos a plus b equals to cos c. Cos can cancel cos. To return back to this, we only brought this cos to be able to simplify things further. Remember that cos multiplied by arc cos equals to 1, isn't it? So easily we can cancel any of these cos in front with the fact that we already have, we're bringing in a cos in. That's just why we are bringing in this cos in, so that we can cancel out this one at the end of the day. But before we continue, we know that cos a plus b equals to cos a cos b minus sine a sine b, isn't it? So we can then say cos a plus x cos a cos b minus sine a sine b. That's what we have here, equals to cos c, isn't it? So now we already know that cos a cos b from what we have here. Cos a is x, cos b is y, isn't it? But we don't know sine, so let's just quickly draw a table for that. If this is a, cos a, if this is a and cos a is x, that's adjacent over hypotenuse x. That means the hypotenuse is 1. For it to be this means hypotenuse is 1. So at the end of the day, it means this place should be what? Then you quickly do Pythagoras theorem. If let's make this place z, then 1 square equals to x square plus z square. We want to make z the sum of formula, so z square will be 1 square minus x square, isn't it? Z will be square root of 1 square minus x square. 1 square is 1. So we can then say this place is 1 minus x square, square root 1 minus x square. So we already know this. Then we can also say the same way, if you do it for b, you also get square root 1 minus y square, as if you do it for b. So let's not bother to waste time doing sine b. You can do it, you can try it out and see. So minus sine a is what? Already know sine a to be, since this is this is z, the last side, sine a will be opposite over hypotenuse, which is root 1 minus x square over 1. So that means it's still same as square root 1 minus x square. So sine a is square root 1 minus x square. Sine b, if you try it for sine b, is also, you also at the end of the day, you also get square root 1 minus y square. So with it's been proved, or it's been proven, whatever English. So that's the answer, proven. That's basically it. Like I told you, you won't be told to prove anything in your exam. It's just for you to understand. So you can treat any other thing like that. Any other question you see on inverse function, once you've gotten to this stage, the next thing you do is whatever the function is, just place it in front. If it is tan, you have been saying, so just put tan here, so that at the end of the day, this cos will be able to cancel out this cos. The cos will be able to cancel out arc cos. That's the reason we brought this cos here and this cos here. So that's basically it, guys. And then I'm going to see you in the next tutorial. Peace.
I am the one, the way you can.